Okay, so we're looking at the guided notes for interval notation. And interval notation, it's just another way of expressing numbers. Um, and I know we've taught you several different ways, but this one is important for us to know because it's used most often in mathematics. Set builder notation is one that we use quite often as well, but I wanted to introduce you to this notation as well. So, just a brief understanding of the number line. One more time. I love this number line because it can be simple, but it could also be fairly complicated if you don't really understand what this arrow over here and what that arrow over there really mean. So here we have 0, and we know that we could go to the negative side. We get -1, -2, and we could keep going this direction for as long as we need to. And on the towards the right, it's going to be all your positive numbers, right? So we have these numbers, and they're written left to right, small to large. So the smallest number, this arrow right here, points towards -infinity. And now I know there's a lot of ideas about infinity and negative infinity especially, but I just want you to know that negative infinity is the smallest. It is the smallest idea of a number. So whenever we want to describe numbers, we real numbers, we need to start with negative infinity because negative infinity is the starting point of numbers, so to speak. It is the smallest that we have, and then negative infinity. Then you start counting all the way until you get to all the negative numbers and -3, -2, -1, 0, 1, 2, and then you keep counting all the way until you get to positive infinity. And no, you will never actually reach positive infinity, and my infinity symbols aren't real good. So, as you notice, I just put two circles next to each other. Some people like to write this figure eight, sideways figure eight. Either way, it's A-okay by me. Just make sure it's not 8. Right? This is not infinity. That's the number 8. Okay, so make sure as you write infinity, if you want to write it all in one motion like that, it's okay. It's going to take some time to get used to. I get that. But we do want to be able to describe all the numbers between negative infinity and infinity. And that's a lot of numbers. So we want to make things a little bit easier on ourselves, especially as mathematicians. Again, we're really lazy people. Really, really lazy people. So then it says currently we can express a set of numbers using roster notation, right? Roster notation where we simply, write out the numbers and list them, right? So that's good for integers and whole numbers and natural numbers, or if just we had, a set of whole numbers, we could write them that way. Or if we had just a few numbers specific numbers that we wanted to use, we could use it in roster notation. And again, we're just listing them in roster notation. Set builder notation, that's the one where you have the set of all x values such that x, and then we have some sort of a comparison here. We describe x this way and this way. So that's our set builder notation. We can also use inequalities to describe numbers. So if we want to say all the negative numbers, we just say x is less than 0. We could use inequalities to describe negative numbers like this. So there's another method. This is the fourth method that I really want you to know and understand well, and that's called interval notation. It's called interval notation because it describes an interval of real numbers. In other words, it's going to describe not just 1, 2, and 3, but 1.1, 1.111, 1.01001, all the way, all the infinite amount of numbers between 1 and 2. It'll describe all those as well. So interval notation uses three symbols, and those three symbols are a bracket. Here I have a bracket, and this bracket means included. And we have a parentheses, and the parentheses means not included. Then we have our union, and it stands for or. But you already knew that. We actually have used the union. The union is what we use in our set talk for Friday. So we know union as well. So when we describe interval notation, or we describe an interval of numbers, we describe them in terms of small to large. And we would do that, let's say it's not included at the small side and it's included at the large side. So we write it small to large. And again, we're just using random symbols here, but I could describe let's put a number line here. And let's say with this number line, we found a solution, or we are given some sort of interval. We want to describe it. Let's say it's the interval of numbers between -2. It's open at -2. We have a closed circle at 4. Here it's closed at 4. And we want to describe this. Here, we'll say it's everything in between, too. So everything in between -2 and 4. Am I included at -2? No, I'm not included at -2. Am I included at 4? Yes, it's closed circle there. So I would describe that as -2, because it's a small one, to 4, because it's the large one. Now we'll get to this union here in a second. I'm going to use this chart down below. I'm going to do several examples. I'm going to show you how that looks with set builder notation and how that looks with interval notation. Okay, so let's get a number line out here. I'm going to do several number lines all at once, just so we have them all. Here we go. Let's get all of our number lines together. Okay. So, let's say this first one is everything from -5 to 5. And we want to say that it's not included at either one. So it's open between -5 and 5. Shaded in between. Okay, so with set builder notation, we'd say it's the set of all x values such that we'd have -5 is less than x, which is less than 5. And so this would be an and compound inequality. For interval notation, I would simply say it goes from 5 to 5. And look, I'm using parentheses because it's not included at 5. Right? That's strictly less than. That's our less than. So it's not included, so we use parentheses. And then whenever I look at, let's say, -10, and let's go to -4. Here's my 0. Let's say it's included at 4, and it's included at 10. We're shading in between here. So this would be, for a set builder, it'd be the set of all x values such that it goes from -10, it's less than or equal to x, which is less than or equal to -4. In interval notation, I put my square brackets. I say it's -10, and it all goes all the way until I get to, oh, that's a -4. And I use my brackets. Well, let's take a look at what an OR compound inequality would look like. So, let's get my 0 here. Let's say it goes at 3. We're open at 3, and let's shade to the outside here. And we're at -7, and it's open at -7, and we're going to shade to the outside. Okay. Now, for this one, I would say it's the set of x values such that x is less than -7, or x is greater than 3. I close my brackets. That's a mouthful there too, right? Well, remember, our number line starts at -infinity and it ends at +infinity. So I want to describe this shaded region here with interval notation. So starting at -infinity and goes all the way until a -7, or from 3 to +infinity. So let's see how that would look in interval notation. Well, I can never actually reach infinity or -infinity, so it's never included. So for -infinity and +infinity, it's always going to be parentheses. So here I say -infinity parentheses, comma.
Good morning. New teacher meeting is in the office conference room at 7:30. New teacher meeting in the office conference room at 7:30.
Hey, that's me. I have 5 minutes to get there. Ooh, whoa, that was scared me. I did not see that coming. All right, so let's describe it with interval notation. Since it's not included, all right, not included at -7 or 3, I would say this to describe the shaded region. It starts from -infinity to -7, union 3 to infinity, and nothing of that is included. So I cannot include 3 because it's an open circle. Let's try another OR compound inequality. Let's see what that looks like. Let's say we have a 4 here. That's 0. Let's say it's closed at 4 and it goes this way. And we're at, let's go 8. And let's say it's open at 8. And it goes this way. I just want to make sure it's loud and clear. That is an open. It is open at 8. Okay. So an interval or set builder notation is the set of x values such that x is less than or equal to 4, or x is strictly greater than 8. We close it that way. In interval notation, we would say -infinity, and again, I cannot include -infinity, to 4. Now that's included because it's a closed dot. And then union, and here we go from 8 all the way until we get to infinity. Let me close it. All right. So we've seen several different combinations here. Again, paying attention to some key ideas. -infinity is always going to have parentheses. Closed dots or less than or equal to, greater than or equal to will always have brackets, and then the strictly less than is going to have parentheses. So I'm going to set this up, and I want you to write it in set builder notation and interval notation and bring it to me, and come bring it to me for Monday morning. Let's see, let's go 0. I like 4, and I like -4. And I want to do open this way. Let's make this an OR compound inequality. I want to do an OR compound inequality. And I'm going to do this. I want to have a closed circle right here. Go that way. So show me this. I'd like to see this in set builder and interval notation.